Another point that I wanted to bring up based on the reading and also just looking over this other document entitled E&M Homework Number One, and I know that wasn't part of our homework, but it was very interesting. It also sort of simulated the activity that we were doing with the electrophorus, where we took the aluminum pie plate and put it on top of a charged styrofoam piece. And here in 7B, problem number 7B, you place the neutral tin foil or foil pie plate on top of the charged styrofoam plate, and then you take the plate off of the styrofoam while holding the styrofoam cup here, and then you put the pie plate up against the knob of an electroscope, and the leaves do not diverge. And so this is kind of interesting because it suggests that the pie plate is not charged at all. Yet it is initially placed on top of a charged styrofoam plate. And so I think what's occurring here, or, as evidenced by the lack of the electroscope leaves being moved, is that the pie plate is merely being polarized but not charged. And so when you take that pie plate away from the charged object, the styrofoam plate, or the styrofoam piece, then the charges that were polarized, that were separated, creating a dipole, mix evenly and become uniform again, thus creating a zero electric field overall. That is a little bit counterintuitive, I guess, in some ways, because I can go ahead and take an insulator that's charged like a glass rod and put it up against a neutral pith ball of an electroscope, and that will actually charge the pith ball. And so in that case, the charged insulator does cause some sort of transfer of charge from the insulator or to the insulator to charge the other object. I think it might come down to the degree of charge that is on the insulator to begin with, and whether or not that transfers to the other object. But insulators, by nature, have problems and prevent mobile charges from moving either onto them or from them, which makes sense. And yet, if you have certain situations like the glass rod, which is an insulator, if that's charged, you can charge another object with it. Is that charging by conduction? Yes, the glass rod is touching the pith ball, but maybe it's a different method, because it's not like the charges can sort of mix evenly among the insulator and the conductor that's being charged, such as the situation with the glass rod and the pith ball when they're touching. So maybe it's more of something different. Physics Classroom website refers to this as charging by lightning, maybe, where it actually ionizes the air, and then the electrons in the air can actually transfer either to or from the conducting object that's being charged. And so that's a very interesting idea, where it's kind of seems to work one way in some situations, but then different in other situations. And the results of my lab, when I did the electrophorus, or even the other activity with the electroscope, where the beyond sticky tape, I found really some confusing results, and they were mentioned a little bit previously on a different screencast. And I would love to sort of be enlightened on this matter in terms of sort of making my thinking become sort of unified to explain all these situations.